Not recording yet.
All right, cool. Let's kick it off. So good morning, good afternoon, good evening, whichever place you're dialing in from. So welcome to another exciting OpenShift Meetup. So my name is Asher Benjamin, and today I'll be your host. With me from Red Hat, I have Andrew Spurgeon, who manages and leads our SA team in New Zealand. I've got Joseph Tihal. Joseph is usually the MC for these events, but today he's taking a break, so he's giving me the mic. And also Michael Calizo, who is a very familiar face to you all. Mike is one of our senior Red Hat solution architects based in Wellington, New Zealand. We hope everyone's doing well and looking forward, I guess, to the break and to the holidays. So today's topic is on migrating OpenShift 3 to 4. So we have education payroll with the help of Deloitte have successfully migrated from OCP 3.9 to OCP 4.5. And today we have the Deloitte team will share their experience and the lessons learned from this migration project. Now, just a short background about Deloitte and Education Payroll Limited, just to kind of set the stage and set the scene for everyone. Education Payroll Limited, or EPL, is responsible for payments of around 96,000 teachers and support staff, and about 2,500 schools every fortnight. So that's quite massive. So over the years, Deloitte Digital and EPL have developed a strong relationship. They've helped them and their stakeholders overcome some of their IT challenges. EPL had a vision to streamline development, test, deploy, and speed to market using a new cloud platform. And they identified Red Hat OpenShift as the platform of choice and engaged Deloitte Digital team to build this new capability. Next slide, please, Mike. So our speaker for today is Everett Taves. Everett is a senior specialist lead at Deloitte. So he focuses on creating platforms that improve the developer experience when it comes to building cloud-native applications. One of his interests is composing platforms from latest technologies, including code containers and cloud. I won't say any more about Everett. I'll let Everett introduce himself later on when he starts presenting. Everett, a very warm welcome to you. And thank you for taking the time to speak in today's meetup.
Yeah, thanks so much for having me.
Cool. So a quick reminder, as most of our meetup sessions, this one will be recorded, so you can watch it again later, or you can share it with your colleagues. Please ask questions in the Q&A box at the bottom. And there's also a chat section as well. So make the session interactive using that available chat box. So comments, feedback, any other things you have in mind, all comments are welcome. So please do make it interactive when you can. Cool. So I'll stop talking and I'll hand it over to Everett to kick off the session for us. Everett, over to you, mate.
Yeah, thanks again. Appreciate that. So I'll just share my screen here. Let me know when you can see that.
Yep, we can see it. Cool. We can hear you as well. That's good.
Great. And I'm in full screen mode now. Can still see it okay?
Yep, all good. Go for it.
Yeah, great. Yeah, so this is the story of OpenShift migration from basically 3 to 4 for education payroll, the team there that I was leading at the time, let's say co-leading at the time. There's kind of a period of transition there as well. And just to introduce myself, Everett Taves, as we already know, I'm eTaves on all the things. If you care to get in contact, senior specialist lead at Deloitte. I'm a platform engineer is the working title. That's the fancy title. Over the past 2.5-ish years, I've worn quite a number of hats at education payroll, but certainly all in the platform area and working on the platform team in various capacities. And you might hear my goofy accent. I'm here in Wellington, New Zealand, via Canada, my home country. Okay, so what are we going to talk about today? Naturally, OpenShift 4. I'm not going to kind of belabor, all the bells and whistles on OpenShift 4, just kind of the compelling ones for us. The migration plan, some of the rough water we hit during the migration. But honestly, there was a whole lot of smooth sailing too because it got done. And what some of the things that we're looking forward to on OpenShift 4. Okay, so OpenShift 4 itself, what was the motivation behind the migration to OpenShift 4? One of the big things was how upgradable it is. There's generally a better day two ops experience. That is just kind of ongoing operations after the initial installation. And some of the bits around metrics were really compelling as well. So what are some of the differences between 3 and 4? The installation varied greatly. The architecture kind of was significantly different, and I'll delve into these in more detail. The new Red Hat CoreOS mutable hosts, that's kind of a significant difference. Now everything's managed via operators, and I'll touch on those a bit, and a completely different user interface as well. So the installation in 4 is radically different from OpenShift 3. So OpenShift 3 was entirely Ansible based. If you've used OpenShift 3, you'll be well familiar with those playbooks, I imagine. The running and rerunning of those playbooks, and it got the job done. But now in OpenShift 4, it's a very different model where you've got these the RHEL CoreOS or RCHOS immutable hosts. They come up and they pull down their configuration from a centralized web server, and they can actually pull, they can get their network configuration from DHCP, et cetera, et cetera, et cetera. So these things basically bootstrap themselves into the cluster, including the control plane. There's a bootstrapping phase, and then the control plane comes up, and then the worker nodes come up. And everything's wonderfully immutable in these RHEL CoreOS, in our case, VMs. The architecture is a bit different from 3 to 4. In 3, you might be used to the control plane with the masters and the infrastructure nodes. You could kind of consider them part of the control plane as well, I suppose. And then you have the worker nodes running your workloads, whatever service it is you're running on OpenShift. But in OpenShift 4, this is the picture we're looking at right now. There's actually only the master nodes for the control plane and the worker nodes for absolutely everything else, right? Including some of those, what you might consider the OpenShift kind of system level services, like the registry and the router, and even Prometheus and Grafana, those metric related services. So really now just 2 types of nodes, masters for the control plane and workers for literally everything else. Back on that immutable operating system, Red Hat CoreOS or RCHOS. So this is a really interesting bit of kit. And it comes from the CoreOS, if you're unfamiliar, was actually the name of a company with a product named CoreOS. That was their flagship product, which was an operating system that was optimized to run containers. So the idea being that this is an operating system that really only runs containers. That's it. Everything is all of its processes are in containers and isolated. And nothing else should actually change on the host except what goes on in those containers. And so, they're effectively considered immutable, and that you get some nice properties, when you adhere to those kinds of constraints, and it makes that whole upgradability piece a lot more seamless, a lot more easy, like because you're also upgrading the hosts at the same time as you're upgrading the OpenShift platform. And that's a really nice to have feature. The second day op stuff, this is largely enabled by this notion of operators, kind of this, I suppose what's effectively a pattern that's kind of come to the forefront. And the foundation of the operator pattern was actually with CoreOS as well. I suppose I neglected to mention that CoreOS was bought by Red Hat, 2 or 3 years ago. And a lot of that technology has made its way into OpenShift, which I think was an excellent move by Red Hat, honestly, because I was familiar with the CoreOS tech even before then, and their Tectonic product, just really good stuff. And I think bringing that into the fold for OpenShift was a good move. And so now, basically everything, all system level services are managed with these operators, and they're effectively controllers, Kubernetes controllers. There's an event loop there, a reconciliation loop running in that little bit of software that's known as the operator, and it's constantly reconciling, what it is you want it to do with the desired state you want the cluster to be in with the state the cluster is actually in. So those things are forever reconciling, your desired state with what's actually going on in the cluster, and it's all managed via those, or most of them are managed via the custom resource definitions. And then the UI, totally new user interface, very different from what was previously done in OpenShift. I'll have more to say about this later. It's good. I quite like it, and some of the admin screens are good. Even just like all of this stuff you see here. All these events and status all green check marks. There's notifications behind all of this stuff, right? But I do have to say, logging into the cluster, basically every day and seeing this every time, it's kind of nice, right? It's just nice seeing all the green check marks, seeing everything kind of well within operating parameters, But you will notice probably that there is one warning here, and I'll also touch on that a little later as well. Okay, so what was the plan for the migration, right? In very kind of broad strokes, we were going to do a proof of concept. We had never touched OpenShift 4 before. We knew it was significantly different between the architecture and the installation. So we just had to feel it out, work it out, wrap our heads around it. Then we'd want to build out the various clusters, do all of the communication and collaboration with all of the teams that depended on OpenShift, the development and testing teams, the ops teams, the business, everybody, right? And then, of course, the cutover from 3 to 4, because you're running clusters in parallel, and you wind up having to cut them over. Finally, not finally, but validation, a crucial part of it, make sure everything's working correctly. And then finally, actually getting rid of the old thing. It's not something you want to forget to do, because it's actually pretty easy to forget to do, or at least deprioritize to the point where these things kind of hang around forever. Okay, so the proof of concept, so many terms got thrown out for this: sandbox, sandpit, dev cluster, what have you. We needed to prove out the whole installation method, which was significantly different, and learn about the architecture, that difference, what losing the infrastructure nodes meant, or how they were replaced, I should say. We had some challenges around running on VMware vSphere 6. It's a rather older version of vSphere, so without some of the bells and whistles. So we literally had to do the bare metal installation mode in order to get this across the line, because we couldn't use any of the fancy automated infrastructure provisioning that actually comes with OpenShift 4. There's another nicety about it that we simply couldn't utilize because of this rather old version of vSphere. And so we wound up making use of this helper node thing, which I'll delve into here. So that was a repo that we came across kind of early, actually, before it even was considered an official Red Hat repo. And what this thing did was build out this so-called helper node where you ran all the services necessary to conduct a OpenShift 4 installation. And so this goes back to that new installation mode that I was talking about, and how the masters and workers reach out to a centralized area for basically all their network configuration, all their configuration, their machine configuration, their OpenShift configuration, everything, right? So running on this old version of vSphere, we had to create our own VMs basically by hand. And when I say we were working with another infrastructure provider. So, we're firing off tickets and stuff, and going through design sessions with them to create the VMs that we need and the networking bits that we need. But ultimately, we got this kind of small sandbox area where we could create more or less what you see here. Although, because at least we had some starting images, we didn't have to do Pixie or TFTP. Those are the two services we didn't have to run. We weren't actually doing like raw bare metal, right? And booting from the tin on up. But we did need to run all of these other services on this helper node. DNS obviously for name server, load balancer, that's actually for the master, the API, Kubernetes API running on the masters, and pointing at the OpenShift routers on the workers, web server to host the images that the masters and workers would download, and the configuration, so hosting both those things. It also acts effectively as a bastion host. And we did use DHCP initially as well, just to make the network configuration a little easier. So the masters or workers would boot up, do DHCP, and get all their network configuration that way. Didn't have to do Pixie or TFTP. And then we even included NFS on there as well, just to kind of emulate storage for the registry. Yep. Yeah, and then there's just, this is us, right? There really wasn't too much else to it in this case. We did run our own DNS for a little while there, but eventually moved off that, when we went to the higher environments. And that all worked reasonably well, actually. Once we wrapped our heads around it and ran it a few times, worked pretty well. So building it all out, going from that proof of concept to a non-production cluster and then a production cluster. So really only 3 clusters, not huge. And like I was saying before, we were actually going to have them alongside each other. So we still had OpenShift 3 running with all of our workloads, our production and non-production workloads on it. Everybody working away on those ones and using those ones, while the platform team built the OpenShift 4 clusters out, right? And trying to do as much as we could on there without actually having users switched over yet. And then something else we wanted to do during the build was make sure that very early on we were doing our actual the builds of our services on OpenShift 4. So we were building our images on OpenShift 4. The production images that we were running, and the non-production images as well that were still in test, and kind of using that also as a litmus test for how well the OpenShift 4 build out was going. And then hit some rough water during the build as well, and I'll get into that more, but eventually some smooth sailing. So that's more on the technical end of things. Really, like, I don't know, 30-40% of it is communication and collaboration with all the various stakeholders of the thing, right? From people right from the ground up, all the developers and testers, other ops people, the people who are just like deploying stuff into production. There's a team for that. There's the business, all the managers, all the Scrum and Agile. So everybody, right? Had to bring everybody into the fold and collaborate with everybody and constantly advertise that this upgrade was coming, right? Basically, every chance we got, if there was ever an org-wide meeting at Education Payroll, we would say, "Oh, hey, don't forget, this is happening. We're trying to hit this window of time. So heads up, this is coming." Just constantly beating that drum that the upgrade was coming. And then, eventually it got to the point where just before switching over to OpenShift 4, we held a number of workshops, with all the developers and testers, the people who are hands-on all day, every day, and basically took them through the UI, took them through the components. Didn't really delve into the architecture, installation, or all that stuff that doesn't necessarily matter to them, but just from a more of a user perspective. And kind of one of the key things that we did was provide effectively a library of bookmarks, because almost all their URLs changed. We had a couple of nice URLs for end users and testers and stuff, but on the whole, probably like 90% of the URLs changed just because of the way OpenShift works, OpenShift 4 works as opposed to 3. There's some difference in the DNS there. So just saying, hey, import these bookmarks into your browser, like step one was literally step one of the workshop. And then of course, like any good enterprise, we've got a change management team keeping us safe. And so, just good collaboration with them and, doing all the change management-y things that we needed to do and making sure those boxes were ticked and the people were happy. And then this made me sad, because we were doing kind of a great big cutover. We cut over for non-prod first, switched everyone over to OpenShift 4. And then there was a 2-week period while, we were kind of letting that settle in before we switched over the production cluster to OpenShift 4. So in that time, we had to effectively initiate a release moratorium. And those are two words that I absolutely hate putting together. And I hope I never have to put those two words together again for the rest of my career. But it was necessary. It would have been nasty if we had tried to, it just would have been ugly if we had tried to release, from OpenShift 4 to OpenShift 3. So we put a release moratorium in there. Okay, so here's what I originally had in my mind for the cutover. Our infrastructure provider has an F5 at the edge. This is where user traffic comes in. It's also manages our internal traffic as well. And we had our OpenShift 3 cluster running, and we wanted to switch to our OpenShift 4 cluster, right? So just boom, we build one completely, and then we switch it over, right? So 3 to 4. 3 to 4, that's the easy bit. So the reality of it turned out to be, we were on 3 and we kind of had a bit of a rocky ride into 4, network-wise, for reasons that there's no real need to go into. But ultimately, it could have been a little smoother, but it is what it is, and we got through it. Then the validation phase, once the cutover is done for each cluster, we had some functional UI tests to run. That's people clicking through things. They had kind of a suite, effectively, of tests that they run. Then there's some automated API testing that fires off. And these are both on all this stuff, all this validation is on the kind of the flagship product of Education Payroll. And so they have this great regression suite of automated API tests, and then finally some performance tests as well. And we've done performance testing, literally from day one of the whole build out, way back and when we were first building out OpenShift 3, right up until, and that gives us the confidence that when we make these kinds of cutovers and are running the performance tests, that everything is still baseline. And of course, we did all of this stuff both before the cutover to make sure, everything was working as we thought it was working on 3. And then we cut over and, made sure everything was working as we thought it was working on 4. And then finally, that decommissioning phase, ultimately that didn't happen until, I don't know, a good month or 2 or 3 after, we finally made the final cutover. And it was just a matter of prioritizing it and getting to it. But definitely needs to be done. You got to decruft things. Okay, another question I often get around this is, how long did it take? How many people did it take? So in terms of calendar time, it was 6 to 8 months. But there's a whole lot of stuff that went on during that time that made it so long. All that stuff around VMware, not being able to automate any of it and having to do a lot of back and forth in order to get the stuff we needed. Kind of same goes for all the networking bits, going through that whole proof of concept phase. That was prioritized and then deprioritized and, kind of working through that. There was a complete disaster recovery exercise, during that time that basically we had to be hands off. And that took considerable time out of the calendar. Lockdown, not to mention lockdown happened during this time. We had staff availability issues, and then, conflicting priorities, which is just kind of normal, honestly. In terms of like real effort and this is not counting the proof of concept cluster, but from when we got the non-production resources, all the VMware resources and networking resources, to when we got that final prod cutover done was really only about 7 to 8 weeks, which was not too bad. And things went smoothly enough that it felt like we hit the target dates that we were aiming at. And it varied from that between that 6 to 8 months for education payroll. The platform team there varied from 2 to 4 people over that period of time, and there was probably another, let's say, 2 to 4 people on the infrastructure vendor side working with us pretty closely on this stuff too. Okay, so the fun stuff, right? The rough water. This is the trench. This is the lessons from the trenches, right? Maybe I should have used a trench analogy, but anyway. So what were kind of some of the rough waters we hit? All that business about vSphere 6 and being older, not being able to automate it. Same goes for all the resources and trying to get all that stuff right. Just being able to get read-only access to things on VMware, being able to see the console and interact with it of the VMs was necessary. Snapshots, managing snapshots, being able to do reboots. That's all stuff that we actually had to get access for just to do this on this older version of vSphere. Kind of likewise with the network resources. And with the way the installation is done, because we can't automate it, what you wind up doing is you boot the VM in VMware, and you got to make sure you get the device boot order correct. So you boot into the console, and then you type in a bunch of kernel parameters, and it kicks off the installation, it kicks off the boot of the VM, which then brings down all of the resources it needs in order to boot up and join the cluster, or in the case of the control plane, actually, create the cluster effectively. So there, honestly, a kind of a significant portion of that time, the effort was us just literally typing in, I don't know, it was probably, let's say, 200 characters per VM, typing it in as kernel parameters because we couldn't copy paste into the console because it's RCHOS and you can't install the VMware tools on it. So, just typing in stuff took time and making mistakes, and having to redo things took time. There was a whole logging infrastructure there is a whole logging infrastructure at EPL, and they send logs out via Logstash. And in OpenShift 4, there's this great logging API thing where you can connect directly to Elasticsearch clusters really easily, and it sends logs directly from your cluster, from each node in the cluster out to Elasticsearch. But there wasn't like a convenient way to configure that to send it to Logstash first. And there was really no recommendations either on how to do that. So what we wound up doing was, kind of rolling our own logging agents. We were using file beats from Elastic and deploying those via daemon set onto the entire cluster. So they're running on all the nodes. And that's how we were getting our logs off the hosts and for all the application services and sending them to Logstash so they could be forwarded on to Elasticsearch. So there's a little more work there involved than kind of the basics. Because our infrastructure provider was using this tool that monitored basically every other Linux system in the fleet with SNMP, still wanted to monitor all the nodes of the cluster with SNMP, which is a reasonable thing to do. Just keep that consistent. But there was definitely nothing out of the box for that on OpenShift 4, which isn't terribly surprising because it comes with its own metrics and monitoring and stuff. So supporting SNMP on RHCOS was a challenge as well. And again, we wound up deploying an agent via daemon set on all the nodes in the cluster with a fair amount of supporting code for that. We actually initially upgraded to 4.4, and that was fine. That was all good. It was just fine. And and then we did some patch point upgrades with 4.4, and it was all good. We were like loving the over the air upgrades as they're called, and just being able to click a button and upgrade it really seamlessly. But then we tried out an upgrade to 4.5 early on, and we found out that the NTP servers were switched, and what they were switched to was being blocked by our firewall, and we didn't kind of realize that for a couple of days after we finally hunted the issue down. And by that time, all of the nodes in our cluster had gotten well out of sync in terms of time. And honestly, the only remediation for it was to burn it all down and start over. We found some code that let us, put in our own NTP servers, configure our own NTP servers. So, we burnt everything down, rebuilt 4.4, reconfigured to use our NTP servers, and then did the upgrade to 4.5, and that worked a lot better. This is just kind of a funny bug. In 4.4, there was this, and it's fixed already. There was this bug where OpenShift was constantly firing an alert because it thought there were too many pods on a particular host, but it was just calculating the number of pods incorrectly. It was counting canceled or exited pods, containers that is actually, in this case, that were being counted against this threshold. And, so it was forever complaining that there were too many pods on a number of hosts, and it was forever alerting, and it was just something we had to eventually ignore. I dubbed it kubelet too many LOLs because you'd come in every morning and look at the console, and there was the alert still. That's that alert that we saw initially in that one screenshot of the user interface early on there. This is one in 4.5 as well. There's a new API priority and fairness API in feature, I suppose, if you will, in OpenShift 4. And what it does is tries to manage if there's like an influx of API calls to the OpenShift API server, you know, it'll try to prioritize those, you know, the important ones, or however you've defined fairness, I suppose, and make sure that the right calls get through and the right calls get responded to. And so this just kind of comes out of the box enabled in 4.5. Kind of the trouble here was the way we had configured Jenkins, which we're using to run our CI/CD pipelines. You know, it was actually monitoring quite a number of namespaces for their builds and build configs, which, you know, ultimately makes a fair number of API calls. And in 4.4, that was just kind of never an issue. In 4.5, when the API priority and fairness feature is enabled, it wound up causing some real issues for us. And eventually we just kind of had to, there's a, you know, a knowledge base issue for it, and you have to kind of work around it. So yeah, I think and there's actually a Bugzilla open for it for our particular issue with Jenkins at this point. And so just working through that. This one's actually not so bad, honestly. Ingress is a little different. You know, the OpenShift router, you know, since you don't have the infrastructure nodes anymore, you don't actually know necessarily exactly where the OpenShift router is going to run. So, you know, either you got to do a labeling strategy or just run it on all the nodes and point your load balancer at all the nodes for application traffic. You know, it's basically you just got to figure out how you're going to manage it. And so that was just a difference to be aware of and get used to. While we were going through the installation process, you know, initially on OpenShift 3, just because of the way things were preferred to be done there in that environment, we had certs on the F5. And so we tried to do and certs for the API, the OpenShift API in particular on OpenShift 3. And so that's where we had our certs. On OpenShift 4, you know, we just kind of sort of naively just assumed that would be just fine. And so we kept our certs on the F5 for OpenShift 4 as well. And we were getting all kinds of problems with the installation. And then after a little bit of back and forth with support, they just said, no, you know, your API internal and OAuth routes must all be passed through TLS, which is fine and it works. But what it wound up doing for us was, you know, we had, because it was passing through all the way to, you know, the various services presenting those certs, we wound up with cluster signed certs exposed to the end users. And you know, after the bookmarks in the workshop, you know, getting users to import the CA for the cluster was the second step. You know, so they wouldn't get hit with an unsigned cert error when they were, in particular, using the OAuth routes, which is part of just signing into the cluster. And then this one is just kind of standard user stuff, like, you know, it's a totally new user interface. So like, oh, thing used to be here, now it's over here, or, you know, now it looks this way and now it looks that way, just stuff like that. So just kind of giving people a run through of the new user interface helped a lot, and, you know, encouraging them to learn from each other as they're basically just climbing the learning curve of how to use OpenShift 4. Okay, so that was all of the rough water, but really, and you know, it probably sounds, there were definitely some sticky spots, like particularly around the TLS pass-through and stuff, and the NTP stuff. But for a large part of it, you know, it was smooth sailing, and everything ultimately worked out. In kind of a funny twist, I felt like the bare metal installation mode was smooth sailing. When I first learned about it and started wrapping my head around it, it kind of, you know, what I read made sense. The pieces in my head fit together, and I kind of liken doing the bare metal installation mode for OpenShift 4 to doing Kubernetes the hard way by Kelsey Hightower for Kubernetes. You get that feel for how all the pieces fit together, how it all works together, where the cogs connect and turn each other. And so I'm sure the automated version of it is wonderful because you click a button and it just works, and obviously that's what you want. But now if I'm doing it with the automated mode, then I actually know what's going on under the hood, and it just provides you with that extra knowledge, that extra level of confidence, I suppose. And so it's at the very least an interesting exercise to kind of go through. Yep, upgrades. Were the actual upgrade process itself was really great. It is literally just a button click. After you've worked out the path that lets you go from one version to another, in the version of OpenShift 4 we were using, you actually kind of had to work that out manually and work that out yourself. From what I've read from some of the, you're literally running some command line stuff to create this graph to understand the path to go from version X to version Y. But from what I've read from the release notes from later versions, that's actually part of the web UI now for the upgrade process, which is exactly where it belongs, of course. The monitoring, this was one of my favorite aspects of it. So just like I said, doing bare metal install mode, helps you understand all the bits and pieces for the automated portion, or what would be the automated portion. For the monitoring piece, like Prometheus, Grafana, and Alert Manager, I'd never actually deployed those by hand. So I'd never had that, kind of Kubernetes the hard way. I've never had Prometheus the hard way experience, right, where I stand up all the components and wire them all together and get it all working that way. It was a bit of a black box for me, but I knew that OpenShift 4 had an operator for exactly these things, right, for the whole monitoring stack for all those components. And we created the cluster. I didn't configure a single thing to do with monitoring. Not a single thing. Created the cluster, fired it up, and boom, there was Prometheus, boom, there was Grafana, boom, there was Alert Manager, all just working. Which, that's the promise of the thing, right? And that was one where it really delivered. I was really happy with that bit. And so now we're using that whole stack for our metrics on OpenShift 4 for all the the system level services and all the user workloads as well. As part of some of our post install activities, the stuff to kind of lay out our whole system, our whole CI/CD system, which I've spoken about in other presentations, and all the other bits and pieces that we need, to have a properly functioning cluster. We wound up using the Ansible Kubernetes module or K8s module, and that worked out really well. So that's if you haven't used it yet, that worked out pretty well for us. We were able to just run some playbooks after the install was done, and it did a ton of stuff for us. Basically took us from post install to fully operational, and we just kind of continue to improve and refactor those playbooks. In the version that we were on, we actually did not have when we first installed to 4.4, there's the left-hand nav in the UI, and it's static. So what's there is there, and that's all you can click on. But if you want to get to certain things, it's literally like 6 clicks to get to some stuff that was like 1 click in OpenShift 3 UI. So one of the nice features in 4.5 is you're actually able to customize that left-hand navigation, based on, you do a search for a particular resource, you can save that as a menu item in the left-hand nav. So it's just now you're just a click away from that thing. So less so on the kind of OpenShift side of things that, we really ran minimal stateful workloads on the cluster. Only the registry and Jenkins were our stateful workloads. So that certainly made the transition, the migration a lot easier. We didn't have a bunch of state to move over. That just a level of complexity that we didn't have to manage. From both the application perspective and deployments with CI/CD, very minor changes. Kind of the biggest one that leaps to mind was, we had the registry URL, the internal registry URL baked into some of our deployment configs. And we had to update those because of their new DNS entries for the internal registry. Really minor there, so that was great. We didn't have to change our pipelines at all. That was awesome. This whole GitOps system we built to do deployments, didn't have to change that at all. And the end result is with this very, very static setup of vSphere 6, where we're actually able to kind of provide that cloud native experience on premise on this aged version of vSphere that's very static. So we're providing something very dynamic on something very static, which I think is a pretty cool story. And we were so gung ho and positive when it came to doing the production cutover. So, we had it scheduled for a Friday afternoon, still during business hours. There was a bit of downtime incurred, like literally just a couple hours. And it actually could have been faster than that for reasons. We had planned an application upgrade the Monday of the following week. And then we're in the change management meeting discussing this. And they're like, yeah, I don't know. If something were to go wrong on that Friday and, you have to remediate over the weekend if necessary, that Monday target for the application upgrade is looking a little tight. But so we backed off and set it for Tuesday. And we hit that no problem. So the Tuesday after the production cutover, we released an upgrade of the application running on OpenShift. Which was also really great. And then here's a quote that I love from one of our developer leads of the development teams, just kind of pinging me on the Monday after the upgrade, for the non-production cluster that they use all day, every day. And everything just worked great for them, and smooth as butter. I love it. So that's what I love to hear from my users, right? And speaking of which, the whole thing was totally worth it because our end users didn't notice a thing. All those school administrators and principals that put all the information into the system, that pay the teachers of New Zealand, they didn't notice a thing. Everything just kept ticking along, and no problem whatsoever. So that was really gratifying as well. Looking forward and wrapping up in the next couple minutes here, what are some of the features we're looking forward to in OpenShift 4? Again, more upgrades. Let's just keep upgrading. We've hit a couple bumps with the API fairness and priority thing, working through those, but continuing to look forward to the thing being upgraded and just getting better and better. Tecton is something we're looking into. We've had our share of issues with Jenkins, and I'm kind of squarely in the not Jenkins camp at this point. And so Tecton is definitely something. If you're unfamiliar, Tecton is like a cloud native, or probably more accurately, a Kubernetes native CI/CD workflow technology. And so investigating that and maybe think about adopting that. Code ready workspaces seem really cool. Kind of toyed with those a little bit. Super handy. and then the Istio service mesh on the thing, finally getting around to deploying that. All good stuff. And that's it. I didn't hear any questions while we were going along there. I should have maybe mentioned that. I would have been happy to take questions while we're going along there. But if anyone has questions, just let me know.
That was great, Everett. There are about 3 questions from the audience. The first one is, I think you kind of slightly touched on it, but see if you want to add anything else to it. Can you please elaborate what challenges you faced in F5 and any learnings that can be shared?
Yeah, no shortage of challenges, to be honest. I think part of the issue was that it was also an older version of F5 that we were deploying to. We didn't have, so probably the number one thing, and it's probably not super helpful to you, is that, we didn't have hands-on access, admin access to the F5. It was, everything had to go through the networking team with our infrastructure provider. And anytime you're in that situation, it's a bit of a challenge, right? Because you're communicating via tickets, or we would get together and do some whiteboarding sessions and be on the phone and stuff. But it's not the same as being hands-on yourself. The bits around the certificates I mentioned, that was a challenge, that's for sure. Not being able to host the certs on the F5 for those particular routes. Would have, for the cutover, would have stood up kind of a separate set of F5 infrastructure for dedicated to OpenShift 4 to make that cutover a little less squiggly. If you recall from that one picture where the cutover wasn't quite as clean as it maybe could have been, if we had simply duplicated some of the virtual servers and stuff within the F5, stuff like that. Hopefully that helps.
Cool. The second question we have from Vincent: during the deployment phase, have you faced some requirements issues running your OCP3 and OCP4 clusters in parallel? For example, vSphere version conflicts, load balancers, Cypher/TLS version mismatch, etc.
Yeah, not so much. Certainly not. It was always, it was the same vSphere cluster, so that version was consistent at least. Environments issues. Yeah, no, it was load balancer, Cypher, TLS version mismatches. No, that stuff was okay. The virtual servers on the F5, that we used for OpenShift 3 were more or less wound up being the same as what we used for OpenShift 4. So yeah, I can't really say we ran into any particular issues in that respect.
Cool. And there's a couple more. I don't know if you can see them on your screen. Hamish is asking around, is patching easier on OCP 4.5 and with more regular updates, for example, 4.6, 4.7, are the patches lesser in size, etc.?
So, yep, easier, 100%. Yeah, much easier. It's honestly really great. It's one of the, I know it's kind of one of the selling points of OpenShift 4, and I think it nails it. Honestly, it's really easy. It is that button click experience for upgrades. Are the patches lesser in size? No. Yeah, no. It brings down the patches, and they're just as big as, at least from one OpenShift 4 upgrade to the next. For OpenShift 3, we only ever did patch point upgrades because we were kind of so concerned about even minor point upgrades that I don't really have a good feel for the patch size on 3. So, but for 4, yeah, same.
Yeah, and I think just want to add there, Everett was telling a story to me that after the migration of the cluster, a week after or the weekend, you guys actually had a major application update as well. So that's, that's the confidence.
Yeah, that's what I was speaking to in kind of towards the end of the smooth sailing section there. That we had scheduled it for the Monday following the upgrade. So like
Ah, there you go. Yeah.
a couple days after the upgrade, and then whoa, and so we did it on the Tuesday instead.
Right.
You'll take that day extra. So and the last one, Everett, it's a good question as well from Michael. What tooling did you use for the migration?
Yeah, that's actually a really good question, and notable in its absence. We didn't. I know there is migration tooling available for 3 to 4, and it kind of comes back to that one point I made about we really run minimal stateful workloads on the cluster. So we didn't have a lot of volumes. We didn't do any volume migration whatsoever. So we didn't need to make use of that tooling. But it also speaks to a point I made earlier on in the presentation that we did our builds on OpenShift 4 as early as possible to kind of prove out that whole flow. But being able to do those builds on OpenShift 4, and because everything's strongly versioned for absolutely every component in the stack, in our stack, we're able to build from source and get exactly what we have at any point at any time, right? For any commit, for any tagged version, and it's all semvered up and down. And so we built the exact production and non-production versions in our new OpenShift 4 clusters. So we didn't even bother copying over images from one registry to the other. We just built everything fresh, but we were confident that we were building exactly what was already there. So those two things combined wound up not having to use any of the migration tooling. And yeah, and all sorry, I was just going to add one last thing. I suppose there's one other aspect to that as well, and that a lot of our stuff was as code anyway. So like our Jenkins configuration was as code. So when we stood up Jenkins, we were comfortable losing the build history, because everything is buildable from versions anyway, and that we just ran with our configuration. We created it with our Ansible K8s modules, doing Jenkins configuration as code, and we're done with it. Sorry, there was another comment there.
No, I was just gonna to see if Michael wants to add anything on the migration tool on top of what you said, but that's fine. Nothing else from me. There's no other questions, I don't think. That was the last one. Cool.
Yes, Ash, just to add, we will be sending out the link to the recording after this session, so you can have it for reference and share it to your colleagues.
Yeah, absolutely. That was an awesome session, Everett. Again, appreciate your time, and honestly, nothing beats hearing from someone that has actually done the work. So that's great. Thanks for sharing your experience. As Joseph said, so go for it.
Just to be clear, there was a whole team behind me. Great group of people. Not by no, I don't want to give the impression that I was some sort of one-man band. Great team at Education Payroll. Helpful the whole time, and likewise with our infrastructure vendor. Honestly, just a good team to be a part of. Sorry, go ahead. If you're talking, you're muted.
All right, Asha, video stop. But I think, as Asha was saying, thank you so much, Everett. There are really good points that you've shared with us, and for everyone who has questions, you can reach out to Michael and me, and so we can help you answer all your queries when it comes to migration and from OCP to OCP2 to OCP4. Anything else you want to add, Michael? You're on mute.
Still on mute.
All right.
Thanks, Everett, for everything. I was excited going through this meetup because I'm
Yeah.
sure I know that we can learn from your experience, and that was awesome.
Cool. Thanthanks everyone.
Great session.
Have a good day.
Thanks, Scott.
Yes.
Enjoy the rest of your day.
Bye.